Hey everyone, and welcome to The Explainer. Today, we are getting into the weeds of some truly advanced LangGraph workflow orchestrations. If you've spent any time building AI agents, you already know that managing how they think, how they decide, and how they act is kind of the ultimate puzzle. So let's break down the underlying architecture of exactly how that's done. Right off the bat, the crucial question we have to ask ourselves is this: how does an AI actually know when it should just talk versus when it needs to take an action? Think about it for a second. A highly efficient AI shouldn't be triggering heavy back-end functions or, scraping the web just to say hello. It needs a brain to route those decisions efficiently. And honestly, that's the core problem we're solving today. So here's our quick roadmap for today's explainer. We'll cover the AI routing problem, the highway metaphor, building the router, enter React agents, and wrap up with parallel tool execution.
All right, part one, the AI routing problem.
Look at the huge contrast here. On one hand, a user just types hi. For that, the AI only needs to fire off a simple natural language response. But on the other hand, the user says multiply 4 and 2. That right there requires a specific function, a tool call, to actually execute. Without a router in LangGraph, man, developers would have to write endless, painful if-else statements just to catch when a user wants a calculation versus a casual chat. It would literally be a maintenance nightmare. Moving right along to part two, the highway metaphor. To really anchor these abstract code concepts, I want you to picture driving down a highway. That highway, it perfectly represents our continuous graph execution. The toll plazas at the very beginning and the end, those represent our start and end nodes. Now imagine a little ice cream shop sitting on the side of the road. That shop represents a specific tool. Maybe it's a math function or a search API. The key here is you don't have to stop at the ice cream shop, but hey, it's there if you want it. So where does the router fit in? Well, the router is basically the exit ramp. It's the conditional logic that decides whether to steer your car toward that ice cream shop or just keep driving straight on through to the end toll plaza. Keep in mind, the router doesn't actually eat the ice cream. It simply makes the decision to take the turn based entirely on what the user asked for. I absolutely love this quote from the source material. The bind tools function puts the shop on the map. This is such a vital LangGraph concept. By binding tools, you are simply giving the LLM the knowledge that the ice cream shop, or say the multiplication tool, is available to use. You aren't forcing the AI to stop there. You're just putting it on the GPS, so the AI knows it exists when it's time to make that routing decision.
Okay, part three, building the router.
Let's trace the actual code flow here step by step.
Step 1, the LLM receives the user's input message. Step 2, the conditional edge evaluates the LLM's response and decides on the route. And step 3, either the tool node executes the requested action, or if no tool is needed, the graph just ends. This flow right here, it's the absolute heartbeat of your agent.
And the real magic component that makes step 2 work flawlessly is called tools condition. It's a built-in LangGraph feature that acts as a super smart decision maker. It looks closely at the LLM's output and dictates if the tool node actually needs to be activated. By routing requests properly, tools condition saves you a massive amount of tokens and compute. It completely stops the AI from spinning up unnecessary tools for simple, everyday questions. Which brings us to section 4, enter React agents. But what happens if things get a bit more complicated? Take a look at this scenario. What if you want the weather in Paris and a nearby cafe? A simple basic router just won't cut it anymore. Why? Because the user is demanding multiple pieces of distinct information that require completely separate APIs. The AI can't just take a single exit ramp, it actually needs to plan a multi-stop road trip. To solve this, we bring in the React framework. React combines reason, act, and observe. It bridges the gap between isolated one-off tool calls and a truly intelligent looping workflow. The LLM gets to think about the problem, take an action, observe the results of that specific action, and then, crucially, decide if it needs to act again before finally answering the user. Let's follow this React timeline for our Paris query. First, it observes the query. Then, it acts by calling the weather tool. Next, and this is the absolute key part, it observes the weather data, reasons that it is still missing the cafe data, and acts again by calling the maps tool. Only after gathering all those puzzle pieces does it finally generate the final output. When you build this out in LangGraph, you'll see a backward arrow in your graph visualization. And honestly, that little backward arrow, is everything. It allows the tool node to return its data right back to the LLM. That backward feedback loop is the exact mechanism that gives the agents its continuous thinking capability. Without that arrow, the AI just takes one action and gives up. But with it, the AI becomes a relentless problem solver.
And finally, Section 5, Parallel Tool Execution.
So consider this. When an LLM triggers multiple independent tools all at once, say, fetching a user's passport, their ID card, and their bank statement, does the tool node wait in line to do them one by one, or does it execute them all together? When you're building agents with dozens of possible functions, execution time scales incredibly fast. It's a huge deal. Well, a real-world test using LangSmith gives us the answer. Let's say tool A takes 3 seconds to run, and tool B takes 5 seconds to run. If LangGraph executed sequentially, it would take 8 seconds total. But if it executes in parallel, it should really only take as long as the slowest tool, which is 5 seconds. And boom, the winning number was 5 seconds. This mathematically proves that LangGraph processes multiple tool extractions asynchronously, right out of the box. As long as your tools aren't mathematically dependent on one another, the tool node triggers them all simultaneously, saving some seriously precious execution time for your users. It's a total game changer. Let's do a super quick recap of our core technical takeaways. First, routers save compute by giving the AI an exit ramp to completely skip unnecessary tools. Second, bind tools acts as a map, telling the AI exactly what functions exist. Third, React frameworks use a backward feedback loop to solve those complex multi-step queries. And finally, the tool node executes parallel calls asynchronously, giving your apps blazing fast performance. Honestly, mastering these fundamentals is absolutely critical for building efficient agents. Which leaves us with this final question for you. How are you going to use React agents to automate your own complex workflows today? The architecture is there, the parallel execution is there, and now you've got the map. Take this knowledge, open up your code editor, and start building your own intelligent LangGraph architectures. Thanks so much for joining me on this explainer, and I'll catch you next time.